Okay, everybody. So we are progressing on our chapter of trigonometry. So up until this point, our main focus has been finding missing sides and angles of a right triangle. These next two lessons, law of sines, law of cosines, are used to find missing angles and side lengths of any triangle. So it doesn't have to be just a right triangle. It could be, but you probably wouldn't use law of sines or cosines. You'd use our normal right triangle trig. But this is used for any triangle. Hence why we don't have a right triangle here in this example. So law of sines is just a proportion between the sine of the angle and its opposite side. So if we look here, sine of angle A is talking about this angle measure over the side across from it is little a, right? So then angle B is across from side little b. And lastly, C is across from little c. So we have this proportion that exists that the sine of angle A over side length A is equal to the sine of angle B over side length B, which is equal to sine of C over side length C. And really, you'll only ever have like two of them, but they just want you to know that all three of them, written as a proportion, are equal to each other. So let's try an example here. So it says use the law of sines to set up a proportion and solve for x. So if we look here, I like to start with the angular side of where my variable would be. So I'm noticing that my variable is a side, and that's across from angle 71. So I'm going to write sine of my angle, 71 over x, is equal to sine 35 over 12. So that's our proportion that we know is true. And a couple of chapters ago, we talked about similarity, or we worked with proportions a lot, and we cross multiply. That's what we're going to do here. So I'm going to take x times sine of 35 equals 12 times sine of 71. Again, folks, we're just solving for our variable here, which is x. So I want to get x alone, so I'm going to divide by sine of 35. Divide by sine of 35. Both sides. This will cancel out. And now, this is just calculator work. You do have to be careful when you type it in. So if you have a calculator, I would just type in the numerator, so 12 times sine of 71. You have to finish out your parentheses. So end the parentheses, divided by sine 35, end parentheses. It equals, and you should be getting 19.78 if you type it in correctly. If you're not getting that answer, you could just type in the numerator, get the number there, and then divide it by the sine of 35. We'll just round to one decimal place, so 19.8. That is basically law of sines. So we'll do a few more examples just to get really good at this. Again, I like to start where my variable is, and that's across from angle 114. So sine of 114 over x is equal to sine of 18 over 5. We'll cross multiply. X times sine of 18 equals 5 times sine of 114. You want to get x alone, so we're going to divide both sides by sine of 18. And now it's calculator work. Type that in your calculator, and you should get 14.8. Okay, one more for good luck on finding missing sides, and we'll try some missing angle measures, all right? So same setup here. Looking for x, that's across from angle 59. So sine 59 over x is equal to sine 73, which is across from 20. We'll cross multiply. X times the sine of 73 will equals 20 sine 59. Want to get x by itself, divide by sine of 73. X equals 17.92, which is just what, folks? 17.9? Awesome. Okay, so pretty straightforward, not much different, but now if you notice, our variable is in the angle position. We start out the same way, but how we type it into our calculator will be just a smidge different. So again, I'm a weirdo. I like to be consistent and do things the same way. Here's my variable. It's across from side length 17. So this time I'm going to have sine of x, because that's where my variable is in the angle position, over 17 equals sine of 91 over 30. Cross multiply. I like to put my variable first, so I'm going to go this way this time. Again, it doesn't matter. I'm just going to keep my variable on the left side of my equation. So 30 times the sine of x equals 17 times sine of 91. Okay, again, you're getting the variable alone. So I need to get x alone. So first we got to divide by 30 to both sides. And now I have sine of x equals 17 times the sine of 91 all over 30, which I know looks confusing. But now remember, we're looking for an angle measure. And how do you undo sine? You take the inverse. I'm going to write it out for this one. So I'm taking the sine inverse of this whole thing. Now we got to be really careful when we type this into our calculator. So let's walk through this one together. Okay, so remember you're going to be in the inverses, so you're going to probably have to shift or hit second. We're in the sine. So you should see sine -1 on your calculator. 17 times sine 91. Have to end that parentheses, you guys, after the 91. Otherwise, you're going to get the wrong answer. Divided by 30. End parentheses. That last end parentheses doesn't really matter so much, but you can put it there if it makes you feel better. And you should be getting like 34.5. If you're not getting this, you definitely typed something wrong into your calculator. So go back and check your parentheses. You could take it in a couple steps. You could figure out what this number is as a decimal, and then type it in your calculator if that's easier for you. But if you're just careful, you shouldn't have to take too many extra steps here. So let's try another one for good measure here. So again, starting with my variable. So sine of x over 26. Whoa! Equals sine of 49 over 25. Let's cross multiply. 25 times sine of x equals 26 times the sine of 49. You want to get x by itself, so let's divide both sides by 25. So we'll have sine of x equals 26 sine 49 all over 25. Now you should be asking yourself, how do I get rid of sine? How do I find an angle measure? We always use the inverse. All over 25. All right, take your time typing that in. If you typed it in correctly, you should be getting, let me extend my page here, folks. 51.71. So we go to one decimal place, 51.7. Okay, and then our last one here. Same song and dance, starting with my variable. Sine of x over 8 equals sine of 105 over 11. Cross multiply. 11 sine of x equals 8 times the x alone, so we're going to divide by 11. And since we're looking for an angle measure, we're undoing the trig function of sine. We're going to take its inverse, so we're going to do sine inverse of 8 times the sine of 105 over 11. Again, it's calculator work, folks. If you can get the algebra to this point, which is just cross multiplying, you're just typing it in, you're ending your parentheses, you're paying attention, you should be getting x equals 44.62 or 44.6. And I guess that's an angle measure, but you should have degrees. My fault. Okay, we're going to finish with kind of a fun multi-step word problem here. It's a good thinker. It says a security camera is located in the middle of the department store. The camera revolves counterclockwise at a steady rate of 1 revolution per minute. At one point in the revolution, it directly faces a beauty counter that is 20 meters from the camera. 4 seconds later, it directly faces a display rack that is 10 meters from the beauty counter. Okay, there's kind of a lot to pick apart here. But like I always say, let's start with the picture. So I know I'm going to have some sort of a triangle. Doesn't really matter, right, what it looks like, but we know we have a triangle of some sort. It says a security camera is located in the middle of a department store. Let's make this point right here our security camera. Then says the camera revolves counterclockwise at a steady rate of 1 revolution per minute. At one point in the revolution, it directly faces a beauty counter that is 20 meters away. So 20 meters away from our camera, so 20 meters away, we have our beauty counter. Four seconds later, it directly faces a display rack that's 10 meters away. 4 seconds later, it's now looking 10 meters away at a display rack. To the nearest tenth of a meter, how far away is a security camera from the display rack? So we're really looking for this. That's what we're looking for. That's our job. We have a lot of things to do in order to figure this out. Oh, I messed it up. Sorry, folks. Can we reverse? I read it wrong. This is 10. And we're looking for how far away the security camera is from the display rack. My fault. There we go. That's the right picture we want. Okay, but we don't quite have enough information to solve this as it is, but there is this piece of information. It took the camera 4 seconds to go from this viewpoint to this viewpoint. How are we going to figure out that angle measure if it makes 1 revolution per minute? So if you think about a circle, right, if it's going all the way around in 1 minute, how many degrees is all the way around? 360 degrees, right? And it takes 60 seconds to do that. So if we want to figure out per second how many degrees it's turning, 360 divided by 60 is 6 degrees per second. And we went 4 seconds. So 6 times 4 is 24 degrees. So we just found this to be 24. So this is a good start to our problem. Because now I have at least 2 matching sides. I know 24 is across from 10. But I don't know what my angle measure is across from x. And I don't know what my angle measure is across from our display rack. And unfortunately, we can't just jump into this position here because we don't have enough information. So it's kind of a multifaceted problem. We first got to figure out what this angle is here before we can solve the rest. So this is just law of sines. So sine of 24 over 10 is equal to sine of y over 20. Cross multiply, we're going to get 10 sine y equals 20 sine 24. Divide by 10. And then we got to take the inverse because we're looking for that angle measure. So if we take the inverse, y should be 54.4. So now we just found this angle here to be 54.4. Now we can easily find our missing angle here, so we can find x. So remember, in a triangle, there's 180 degrees, so minus 24 minus 54.4, and we get 101.6. So now we can use law of sines one final time to figure out what the distance between the security camera and the display rack is. Always go back to like your constant ones that you didn't approximate. Since we approximated on this angle, let's use the 24 and 10. So I have the sine of 24 degrees, which is across from side length 10, is equal to the sine of 101.6 degrees over side length x. Now you have a problem that you've been doing, I guess, all lesson, right? Cross multiply x sine 24 equals 10 sine 101.6. Divide by sine of 24. 10 sine 101.6 all over sine 24. Type that into your calculator. We should be getting 24.08. So 24.1 if we want to round to the nearest 10. Feet, what are we in? Meters. So the distance between the security camera and the display rack is 24.1 meters. Kind of a fun problem, getting to practice both, finding missing angles and sides. Okay, folks, thanks for watching. We'll talk to you next time.